So as you can see from my affiliation, I am from a tropical meteorology, not from a national supercomputing center or anything. So that tells you I am a user of HPC mostly, but we have one of the largest system that is being used in India. So these are the major HPC centers in India, wherein we have. So we have academic HPC centers which cater for various applications, starting from weather, climate, drugs, and physics, material science, and all other stuff. So there is another center for development of advanced computing HPC that they also host a lot of HPC centers, and CSR is a center for scientific and industrial research. They also have a lot of centers to do mostly industrial research and weather and climate research. And ISRO mainly deals with space applications and astronomy. And MOS is where I belong to, Ministry of Earth Sciences. It is where weather and climate modeling and geology, geophysics, all other applications will be run on this year. So there are other R&D centers, and private also have some HPC centers. So mostly in India, most of the applications are dominated by weather and climate at present. But there are others, for example, MOS, we have about a 1.2 petaflop system, which is fully dedicated for weather and climate modeling, and there is a center for development of advanced computing. They also do a lot of weather and climate modeling, and CFT, drug discovery, and other activities. And CSR, again, weather and climate modeling. As you can see from all these things, the weather and climate modeling dominates HPC applications in India at present. But now slowly other fields are catching up, and this is India's share in top 500. So you can see that if you look at the number of systems in India are in top 500 in the last Monday's list are about 9, is about 2% approximately. Not very good, impressive figure, but if you look at the performance wise, it is only 0.8%, but the rank wise it stands at 7. So this is very bothering figure for India, but just like top 500, we also have a list in top supercomputers in India. So they also follow same methodology as top 500, and it is mostly done by IISc Supercomputing Center. So I'll just give you some details from this. So this is India's share in top 500. You can see that we have managed to have our place in top 100 for almost several years, and now we are dropping down in recent times from 14, 15 onwards. Our figure is going beyond 100. So this is the place, and we are almost very on top, about 4 when sometime in 2007-8 with the Ekak supercomputer 4th place. So the situation is becoming worse day by day, but the figure is dropping in the top 100 list as well. And the number of computers also goes into different seesaw. Sometimes we are having 12 systems, sometimes only 2 systems, again 12 systems. So it is going on based on that funding that we receive at different times. So again, here I am showing you what are the fastest and slowest supercomputers in top 500. Those are the continuous lines, and dashed lines. Also, dashed lines are the one from top 500, and continuous lines are the from top supercomputers in India. You can see that the gap between the slowest supercomputer in top 500 and slowest supercomputer in India is almost remains same, but the gap is increasing as you go from fastest supercomputer in India and fastest supercomputer in the world. The gap is increasing. So we are trying to increase the capacity by increasing more number of systems, but at the same time we are not able to catch up with top supercomputers in India by enhancing our capability of one single system. So this is again the performance of supercomputers within India. So you can see that the minimum supercomputing capacity is increasing from sometime 1 teraflops to now 20 teraflops, and the maximum is number 1 petaflop systems are in place in India now. So this is mostly the OEMs that most of the OEM contributor is HPE. which has almost about 15 systems, and followed by IBM and other systems, and mostly Intel GN processors are used most of the time. And this is the list for the top 10 supercomputers. We have about 33 supercomputers which are above 20 teraflops right now. So these are the top 10 supercomputers in India. The first one is at IAC, which is about 1.2 petaflops computing at the R peak, and LINPACK is about 900 teraflops. So they do most of the work on weather and climate modeling, and also the different fields of physics, chemistry, and other CFD problems as well. So the second comes my institute. In Institute of Tropical Meteorology, we have a iDataPlux system, which is about 790 teraflops, and with LINPACK it is 719 teraflops, and we use dedicatedly for ocean atmosphere modeling only. And there is another institute from TIFR, Tata Institute for Fundamental Research. They use the system for studying material science at very extreme high temperatures. They have about 560 teraflops, and with LINPACK, but 730 with R peak. So if you look at all of that again, so now earlier we used to have only weather and climate modeling most dominating, but now other fields are coming up very slowly. Now a new player is the oil and natural gas also coming, exploration also coming into picture. So there are several players which are coming. Mostly all these computers are funded by government. So private players also are there in the top 100 list, but here I am not showing you. The top 10 supercomputers are mostly funded by government. So this is just to give you a summary of the top supercomputers in India. We have about 5.4 petaflops of cumulative computing capacity in India, and there are 3 new entries which came recently. And for deciding the top supercomputer, the minimum criteria is 20 teraflops in India, and the average per pascal is 163 teraflops. So far the statistics don't show a very encouraging figure. So the government of India has felt that there should be a great need to launch different mission mode projects, and there are 2 different missions are launched for enhancing our HPC capability and capacity. So first is, these are the 2 first clips which have appeared in last 2-3 months. So first is with 720 million national supercomputing mission. Though it was talked about so many times earlier, but final approval and all came last year or this year, and now they are ready to go ahead. So about 720 million is approved and sanctioned for national supercomputing mission. I will give you details about what is that. And another one is there's a monsoon predicting supercomputer for about 60 million. So there a lot of investment is being put up by government to enhance our supercomputing capability and capacity within India. So coming to national supercomputing mission, even though it was talked many times, but now final approval has come recently, and it is a 7-year project with a budget of $700 million US. So implementing agencies are mainly IASC, Indian Institute of Sciences, Bangalore, and CDAC, Pune, Center for Development of Advanced Computing. So the major objective of this is to enhance the capability in solving grand challenge problems of national and global relevance by using HPC, and to set up all these different state-of-the-art computers at different places in India. So this is the structure. This is a very preliminary, but yet to be finalized. There will be multiple metaflow systems, about 6 metaflow systems will be set up at different R&D organizations and academic institutes, and 200 to 500 teraflops about 12, and 10 teraflops about 20. So like that, there are several systems will be set up and will be called National Supercomputing Grid. So all these will be connected through National Knowledge Network. So the scope of the mission is to have these different types of computers, entry-level, mid-range, and large computers, as I showed you earlier, and building National Supercomputing Grid by interconnecting all these systems through NKN. So most importantly is that HPC manpower development, that also has been part of this National Supercomputing mission. So this mission is expected to create, I have already talked about this, to create about 20,000 scientists working on HPC. So in next 7 years, such that is a big challenge of National Supercomputing mission. And without that, we cannot really make very grand progress in this. So the government is really going into details and they also started some PG level diploma course to encourage young scientists to work on HPC and HPC related applications, software, hardware, all those things. And the whole goal is to create about 20,000 strong manpower to be deployed in next 7 years. So the current status of this mission is that it is already initiated, and in the next 3 years, some new HPC will be installed and be ready. Our rank in top 100 may be improved within next 3 years. So other institutes also, they take care of a lot of initiatives. Then another is Center for Science and Industrial Research, Council for Scientific and Industrial Research. They are also having multiple petaflop systems that will be coming very fast. And others are TIFR is also looking at petaflop systems. And our own ministry, Ministry of Earth Sciences, is also looking for multiple petaflops. Maybe next year we will have about 20 to 30 petaflops system in place. So with that, I'll stop. Thank you.